Okay, good morning. We're going to continue on and talk about different ways to evaluate limits algebraically when substitution doesn't work. And that talks about indeterminate forms and how to transform and substitute when we do have indeterminate forms. So just to review, substitution can be used to evaluate limits when we know it's continuous. So f of x equals x to the negative 2 is continuous at x equals 3. So I could simply substitute this in to find that the limit as x approaches 3 of f of x is 1/9. However, sometimes when you do that, you're going to end up with an indeterminate form. For example, 0 over 0, infinity over infinity, infinity times 0, or infinity minus infinity. When this happens, we have to change the function algebraically when possible and then use substitution. So for example, we have the limit as x approaches 3 of this function here. Now, if I did direct substitution here and simplify the numerator and denominator, I end up getting 0 over 0. So since we have an indeterminate form here, we are going to transform this by factoring like you did in Algebra 2 and pre-calc. So I'm going to rewrite the numerator as x minus 3 times x minus 1, and the denominator as x minus 3 times x plus 4. By doing that, I can simplify, cancel my x minus 3's, and then find the limit as x approaches 3 of x minus 1 divided by x plus 4. Now I can use substitution. 3 minus 1 over 3 plus 4 gives me 2/7. So my final answer here is 2/7. I do want to caution you because in calculus on the free response, you could lose points if you have linkage errors, meaning if you put equal signs between things that aren't truly equal. So I did use equal signs here. Just be really careful. I'll make sure I show you when linkage errors do occur. Okay, next one, I have a typo in here, so we're going to go ahead and fix that right away. This should be pi over 2. At pi over 2, if you think of your point here, we have the point 0, 1. So tangent is 1 divided by 0, which is infinity. And secant is 1 over cosine, which is also infinity. So since we have an indeterminate form, I'm going to write this differently because I don't want that linkage error. Tangent of pi over 2 equals infinity. Secant of pi over 2 also equals infinity. So there's our indeterminate form. Let me erase this real quick. Okay, so what we're going to do is we're going to simplify. I'm going to show you another way to avoid linkage errors. Tangent of x over secant of x can be simplified and rewritten as sine of x over cosine of x divided by 1 over cosine. So remember, we could multiply by the reciprocal of the denominator, and then I wrote it the wrong way. So I'm going to multiply by cosine of x on both sides, on both the numerator and denominator. So that cancels with that cancels with that, and we end up just having sine of x. So this is equal to the limit as x approaches pi over 2 of sine of x. Well, at pi over 2, our sine is simply 1. Okay, next one. We have the square root of x minus 2 over x minus 4. When I substitute that in, I end up getting 0 over 0. Now this one is a little different. When you see these square roots, we're going to use conjugates, and you haven't heard about conjugates for a while, but if I have a square root there, the conjugate of this polynomial is the square root of x plus 2. So if I multiply by the square root of x plus 2 on both the numerator and denominator, we are going to get on the top the square root of x times the square root of x, which is x. Square root of x times 2 is 2 square root of x.
MJ, please call 2145. MJ, please call 2145.
Apologize for the announcements there. So distributing all that out, we get 2 square root of x minus 2 square root of x cancel, and then we have x minus 4. I'm not going to multiply the denominator. X there, sorry. Because now I have x minus 4 in the numerator, and in the denominator, so I end up getting this. Because the numerator cancels with the x minus 4 on the bottom. So that cancels with that, and we're left with 1 up there. So now I can substitute. 1 over the square root of 4 plus 2 gives me 1 over 4 for a final answer. Same idea for the next one. We have a square root. So if I substitute 5 in, I get 5 minus 5, and I get the square root of 5 plus 4 minus 3, which is 0 over 0. So that is indeterminate. Make sure I check that all the time before I try to work it out. So we're going to use conjugates again. But this time I'm looking at the denominator because that's where my square root is. So I'm going to multiply by the square root of h plus 4 plus 3 over the square root of h plus 4 plus 3. And in the numerator, I'm going to keep this as it is. And in the denominator, when I multiply it out, I get h plus 4 minus 9. And when I simplify that, I end up with this canceling here. So I'm really going to find just the limit as h approaches 5 of the square root of h plus 4 plus 3. So when I substitute 5 plus 4 inside my square root and then plus 3 gives me 6. Next one, we are going to simplify by combining those fractions together because when I substitute, I get 1 over 0 minus 2 over 0, which is infinity minus infinity. So 1 over 0 minus 2 over 0 is the same as saying this. So what I'm going to do is I'm going to factor this, x plus 1 times x minus 1. And then I learned that I need to multiply that first fraction by x plus 1 over x plus 1. So I end up finding that the limit as x approaches 1 of x plus 1 minus 2 over x plus 1, x minus 1 can be simplified then to the limit as x approaches 1 of x minus 1 over x plus 1 times x minus 1. Those cancel. So now I have the limit as x approaches 1 of 1 over x plus 1, which is 1 over 2. I hope you're seeing now very clearly why we wanted you to review your algebra skills this summer. Okay, next one. When I substitute 2 squared minus 2 plus 5 gives me 4 minus 2 minus, or plus 5. So 4 minus 2 is 3, plus 5 is 8, and then 2 minus 2 is 0. This is not an indeterminate form. So what you need to do is look at the left side and the right side. So if I do the limit as x approaches 2 from the left of x squared minus x plus 5 over x minus 2, and the limit as x approaches 2 from the right, I'm going to let you go ahead and graph that real quick and check it out, or look at the graph in your book, and I can actually pull that up if you'd like to see it. But on the left side, it's going to negative infinity. On the right side, it's going to a positive infinity. There's actually an asymptote there. So what we would say is that the limit does not exist there. Okay, and again, look at that graph. You'll definitely see that it's not continuous. Last one. Okay, simplifying this one out. If I plug in 0 here, I get a squared minus a squared over 0, which is 0 over 0. So indeterminate. We are actually going to simplify this by multiplying out this group here. So I'm going to have h squared plus 2ah plus a squared, and then minus a squared over h. And I'm going to simplify, so this simplifies. And I'm going to factor out an h. So I have h plus 2a in the numerator, and then the h in the denominator will cancel. So when I substitute this, I end up getting 0 plus 2a, which is just 2a. Okay. That's it for algebraic manipulation. Definitely need to review factoring, conjugates, and a few other trig values. If you have any questions, don't hesitate to ask. Your assignment's posted. Have a great day.